Hey guys, happy Thursday. We are going to start a new unit today. We're going to start Unit 3, which deals with angle relationships. And again, you are expected to, by the end of this unit, be able to form arguments to establish facts about the angles, sum, and exterior angles of a triangle. The angles created when parallel lines are cut by a transversal, and the angle criterion for similarity of triangles. All right, so what I've highlighted is what we're actually going to focus on today, which is the angles created when parallel lines are cut by a transversal. Okay, so we're going to go over basically today a lot of vocabulary, so that way we can understand the relationships better for tomorrow. So what I included in today's folder is also a wrong assignment. Also a notes page for you to follow along if you'd like. It looks like this, where there's already text box that you just have to type in. And then again down here, you can drag these little circles and identify the angles that we're talking about, for example, like this, and so forth. Okay, and then you can drag them back wherever they need to go. Okay, so again, if you want to, go ahead and pause the video, open up this notes page, and kind of do like a split screen, so where you can fill in the notes and watch the video at the same time. Okay, and with the notes page, they are in order, so the order that they are on the notes page is the order that they're going to come in the video. All right, so I'm going to put that away for a second. All right, so first things first, let's talk about what we already know. So we've already discussed in previous years types of angles, and this is just a quick overview of the angles that you should already know. So we have the acute angle, which is less than 90 degrees, okay? We have the obtuse angle, or the right angle, which is exactly 90 degrees, okay? We have the obtuse angle, which is greater than 90 degrees. We have a straight angle, which again from one side to the other, one side to the other is 180 degrees, okay? And let's see, what else? Supplementary angles are two angles whose angles measure add up to 180. So again, they're on this straight line here, and then it's cut by another line, which again forms two lines. But since it's on a straight line, the reason why we know that it adds up to 180 is because, again, from the previous, a straight angle is 180. And if this is just being cut in half, then it's just separating that 180 into two parts. Complementary angles, okay, is when you take a right angle and you separate it into two parts. So again, if the right angle is 90 degrees, then again, angle 1 and angle 2 added together also equal 90 degrees. And the adjacents are just two angles side by side, okay, with a common vertex and a common side. I apologize for the bells, guys. All right, second thing we want to talk about and discuss and review really quickly are types of lines. So again, we have our parallel lines, which again are lines that never cross and they stay the same distance apart. So even if I drew these lines and I kept going and going and going, them being parallel means that they would never touch at any point. Okay, secondly, we have the intersecting lines, which again is two lines that pass through the same point. So here we have line Z and line G, and they pass through the point R. Okay, so that's their intersection. They intersect at point R, meaning they cross or they cross paths. Okay, and then lastly we have perpendicular lines, where again it's a vertical line and a horizontal line, and where they intersect forms a 90-degree angle or a right angle. All right, so these are just some review things that we are going to use for this unit. So let's actually get into what we need to learn. So it says angles and parallel lines. We will consider the angles formed by a pair of parallel lines cut by a transversal and their properties. Okay, first off, we have our set of parallel lines here. We have line A and we have line B. it is cut by the transversal, which again is just a line that cuts through. So K, this orange line here, is our transversal. Okay, meaning it's cutting through those parallel lines. All right, then it says when a transversal K intersects parallel lines A and B, 8 angles are formed. So if you notice, I numbered the 8 angles. 1, 2, 3, 4, 5, 6, 7, 8. Okay, the types of angles formed are listed below. So this group right here are all the angles that were just formed by this transversal cutting through these parallel lines. And we're going to go through and this is where you'll be filling in that vocabulary. We're going to go through each angle, and I'll show you an example of where they were formed. Okay, so our first one is vertical angles. Okay, so vertical angles is a pair of opposite congruent. Okay, so opposite goes in that first blank if you're filling in the notes. Opposite congruent angles formed by intersecting lines. Okay, so here an example, and again this part right down here leaves us for an examples. Vertical angles could be angles 1 and angle 4, because again here's our line A. Okay, and it was cut by this transversal or intersected here. So our vertical angles would be the ones that are across from one another when that was formed. So 1 and 2. And again, to represent angles, we use this little angle sign, angle 1. And also with them being opposite, the key word here is congruent. Okay, if you remember from elementary school, congruent is just another word for same, meaning they have the same measure. Okay. So angle 1, and to represent that, sorry guys, another bell. Okay, angle 1 is congruent to angle 4. And another pair would be angle 2 and angle 3. They are opposite one another when that transversal was made. Okay, and again, we can also look at this section down here because again, another 2 sets of vertical angles were also created there. Okay, but let's move on. Let's move to supplementary angles. So a pair of supplementary angles formed on a line when cut by a transversal. So again, when we look back at those angles on that third page, supplementary angles are angles that are formed by a straight line, which is here, again, line A. Then it's cut by this transversal. Okay, so the supplementary is here. If line A is a straight angle, from here to here is 180 degrees. So angle 1 and angle 2 are supplementary because if we add them together, since they make that straight angle, they're going to be 180 degrees every single time. Okay, another set would be, so angle 1 and angle 2, okay, are a pair of supplementary, you know what, I'm going to erase that. Oops, wrong one. Okay, so, sorry, one pair would be angle 1 and angle 2. Another one could also be, even if we look at line B down here has done the same thing. The transversal cut through this way. So an example of these supplementary angles would be angle 7 and angle 8 because they're on that straight line. And we know that no matter what, this straight line is equal to 180. Okay, so angle 7 and angle 8 are also supplementary angles because if we add them together in this, on your notes page, again, supplementary angles added together should equal 180 degrees. Okay, so there's several different pairs here. There's also supplementary angles here, 5 and 6. Okay, and then again 3 and 4. All right. We could also, if we looked at it sideways, this way, if we looked at angle 2 and angle 4, we could also say that those were supplementary as well. Okay, so several supplementary angles here, all because those straight lines are being cut by that transversal. So let's move on to the next vocabulary term. Next we have corresponding angles. So corresponding angles are angles that lie on the same side, again if you're filling in your notes, same side of the transversal and in the same or corresponding, actually is the correct word to use, corresponding positions of lines A and B. Corresponding angles are congruent. Okay, again, congruent means that they're going to be the same measure. They're equal to one another. All right, so what does that mean? Angles on the same side of the transversal. So if we look, the transversal cuts this in half. Okay, so over here on this side, we have the left side of the transversal and we have the right side of the transversal. Corresponding angles are going to be on the same side and in corresponding positions. So here, if I look at angle 1, angle 5 is its corresponding angle. They're in the same position. They're on the left side of the transversal, okay, and on top of the lines, okay, so they're in the same position. Another example could be, let me get another color here. Another example would be 3 and 7. Corresponding angles are on the same side of the transversal, okay, and in corresponding positions. So here we have angle 1 and angle 5, angle 3 and angle 7, and we could keep going. There's several corresponding angles here. There's, let me pick this one, 2 and 6 are corresponding, but now again, this is on the right side. They're on the same side, but now they're on line A and line B. So again, angle 2 and angle 6, and we could keep going, so on and so forth. Okay. Next, and again, please make sure, again, if you're filling out the notes, you can pause the video at any time and drag and drop those circles to represent the example of each type of angle. Okay. And let's see, the next one we're on to is alternate exterior angles. Okay, alternate exterior angles. Okay, so is a pair of angles that are outside, okay, outside the parallel lines and on opposite sides of the transversal. Okay, alternate exterior angles are congruent. Meaning, again, these are all the same as well. First off, the word exterior. Okay, exterior lends itself to being outside. Okay, now if we were looking at an example, let's see, angles. So on the outside of the parallel lines, so again, this is exterior. So angle 1 and angle 2 are considered exterior because they're not between the parallel lines. And then 7 and 8 would also be considered exterior angles because they're not inside the parallel lines. They're on the outside. So now that that's said, now it says, and on opposite sides of the transversal. So here an example would be angle 1, which is an exterior, but now it has to also be on the opposite side. So this would be angle 8. Okay, so they're both on the exterior and they're on the opposite sides of the transversal. So angle 1 and angle 8. And then if we look further, there's another set, angle 2 and angle 7. Again, on the outside of the parallel lines, but on opposite sides of the transversal. Okay, so it's two sets there, angle 1 and angle 8. and angle 2 and angle 7. And again, they are congruent. So for example, if angle 1 is, it looks like an obtuse angle. So if I were to say angle 1 is 95 degrees, since these are alternate exterior angles and they're congruent, that means angle 8 would also be 95 degrees. Okay, so again, they're on the exterior or outside of the parallel lines, but on opposite sides of the transversal. And again, they are congruent, meaning they're equal measures. Okay, next one is alternate interior angles. So now we're talking about interior. If we were just talking about the outside, hopefully interior reminds you of a pair of angles that are inside or in between. We can just put inside. And then in parentheses, I'll put in between. Okay, in between the parallel lines and on opposite sides of the transversal. Okay, so now we're talking about interior, which now, instead of talking about the angles on the outside of the parallel lines, we're talking about the angles on the inside of the parallel lines, the interior ones. So that leads us to look at angles 3, 4, 5, and 6, because they're in between those parallel lines. Now again, the key thing is they're on opposite sides of the transversal. So that means angle 3, if we look at angle 3, if we look on the opposite side, angle 6 is its alternate interior angle. Okay, so here we have angle 3 and angle 6, and then we have angle 4 and angle 5. And like I said earlier, these are congruent, meaning again their measures are equal. So if the measure of angle 3 is, let's say, 60 degrees, then the measure of angle 6, since they are alternate interior angles, is also 60 degrees. Okay? All right. Moving on, so that was the alternate interior angles. The next one, let me pick a different color here. The next one we're going to talk about is same side interior angles. So again, in the vocabulary term, it kind of tells you which angles we're going to be looking at. We're going to be looking on the same side, and we're going to be looking at the interior angles. So we said the interior angles are again in between or inside. So that goes in that blank there. You could either put in between as well. The lines, and now we're looking on the same side. Again, because in the name it says same side of the transversal. The same, and then it says the same side interior angles added together are going to equal 180 degrees. Okay, so let's look. Let's focus on, again, if they are talking about interior, they're going to be the angles between the parallel lines. And now we're looking at the same side of the transversal. So if the transversal is here, this is our left side, and this is our right side. So, for example, 3 and 5 are same side interior angles. They're both on the left side of the transversal, and they're both in between or inside the parallel lines. So angle 3 and angle 5. Okay. Now, if we look to the right side of the transversal, okay, we see angle 4 and angle 6, both interior angles and both on the right side. So angle 4 and angle 6. Okay, and if we took a protractor and we measured their angles, if we added these together, they would equal 180 degrees. All right. Okay, so again, remember, interior, in between the lines, same side. Again, they're either all going to be on the left or they're all going to be on the right. All right, and it leads us to our last term, which is same side exterior angles. And just like it sounds before when we were talking about alternate exterior angles, exterior, they are going to be outside, okay, outside the parallel lines and on the same side. All right, so again, if you remember, we talked about the outside. If these angles are on the interior, then this is the exterior at the top and the exterior on the bottom. Okay, they're outside of those parallel lines. They're not in between. Okay, and it says same side exterior angles, again, are going to be added up to 180 degrees. So, and again, we have our transversal that cuts through, and we get a left side and a right side. All right, so again, let's read the definition. A pair of angles that are outside the parallel lines and on the same side. So that means angle 1 and angle 7 are same side exterior angles. Angle 1 and angle 7. Okay, that's on the left side. If we look on the right side, we can see exterior outside, angle 2 and angle 8. Okay, angle 2 and angle 8. Again, they're both on the exterior and they're on the same side of the transversal. And again, if we took a protractor and we added their angle measures together, they would equal or add up to 180 degrees. All right, guys, so that's the last vocabulary term. Again, this was your notes page. Again, go back and watch the video as many times as you can. Fill in the notes as you go. Drag and drop the little circles, okay, to remind you of examples of what type of angles are being represented. And there will be a vocab quiz on Monday. I also added in this folder today a Quizlet, which is a flashcard of all of these vocabulary terms as well. So if you want to have both of those screens together and fill in the notes, you can also do that as well. But again, that's it for today. I hope you have a great day, and I will see you tomorrow.